Yes. Is the screen visible to you?
Yes, sir.
Okay.
Yes, sir.
Now today we are going to go to, okay. Earlier what we did, mean, median and mode was measures of central tendency. We did measures of central tendency. Now there is one small element which is left in measures of central tendency, and that is sometimes they ask you geometric mean. Now you cannot give a complete solution on this because you all are not allowed scientific calculators and neither logbooks are available. So basically geometric mean is not that difficult. I'll just give you a sum. You can see the sum which I'm writing right now. This is the raw data given. For raw data it'll be asked mostly. Okay, so they say geometric mean find geometric mean for the following data. So the data is given to you, so you can write it down in your books, please. Find geometric mean for the following data. Okay, now under geometric mean what you have to do here is basically it will be written like this. When you're doing geometric mean, that is 2 into 4 into 8 into 16 into 32. These are how many numbers? 1, 2, 3, 4, and 5. So you'll have to do raised to the power of 1 by 5. Sorry, 1 by 5. Okay. Now you can either leave the answer here in the exam, or it also says the fifth root of solution of this is 2 into 4 into 8 into 16 into 32. So you'll have to leave your answer here. But in this sum we can proceed. Now this is the way you approach all other sums, which I'm going to show you another sum in some time. But this sum, there is another alternative way of doing it here in this type of sum. Now, how do you know these type of sum? If you observe, all here are in multiples of 2. Can you see this?
Yes, sir.
So if you say first one is 2 into 4 means 2 raised to 2, correct? Because 2 into 2 gives you 4. 8 is 2 raised to 3 because 2 into 2 into 2 equal to 8. Now if you do 2 into 2 into 2 into 2, you will get 16. So this will be 2 raised to 4. And similarly 16 2s are 32. So if you see 4, 2 into 2 is 4. 4 into 2 you get 8. So for 8 you have 2 3 times. Now 8 into 2 you get 16. That means you have these 3 2s plus this 1 2. So 4 2s. Now 16 into 2 you get 32. So that means you have these 4 2s here and this one. So that means 2 raised to 5. Okay. And 1 upon 5. Further you solve this, the rule of indices says, when the bases are same, suppose you have like this, a raised to x into a raised to y, a raised to x into a raised to y, the base is same, a and a, then your final answer becomes a raised to x into y, or rather a is equal to xy. Okay, so basically in simple words, if it is a raised to 2 into a raised to 3, your answer final will be a raised to 5. This is the rule of indices. So basically when your base is this part here is same, the raised to the power of gets added if there is a multiplication sign. Okay, then you will have to do your 2. Now this is 2 plus 3 plus 4 plus 5. How much does that come to? Because the bases are same here. See everywhere 2, 2, 2, 2 and 2. And there is a multiplication. So you'll have to do on the top, you'll have to do 2 plus 3 plus 4 plus 5. Is that clear?
Yes, sir.
How much does that come to? And this is the one.
14, sir.
15, 15. This is 2 raised to 1. You'll have to take that also,
Acha,
beta.
okay.
I
Then
just wrote it
15.
2. This is 2 raised to 1. See again, children. This is 2 raised to
1.
So that one also has to be added. So that will be 1 plus 2 plus 3 plus 4 plus 5. So you will get 2 raised to 15. Okay.
Yes,
And
sir.
brackets is 1 upon 5. Okay. Now, one more thing about fraction. Suppose you have a fraction like this. 1 upon 2 into 1 upon, say, 4 upon 3. Or rather 4 upon, not 4 upon 3, my mistake, 2 upon 3. Now, this is a fraction. How do you multiply fraction? See, when there is a multiplication sign, you have to just multiply the top into the top and the base into the base, which you cannot do when it is, suppose it is 1 upon 2 plus 2 upon 3. You cannot do directly these two add and these two add. No, that is not possible in fractions. What you're supposed to do is you can do that only when it is a multiplication. So I have here half into, into 2 upon 3. If this is the case, what you will do is your solution will be 1 into 2 upon 2 into 3. So your final answer is going to be 2 upon 6. And you can further simplify it by dividing this by 2. 2 ones are, 2 threes are. So your final answer will be 1 upon 3. Now why I'm telling you this is because this is going to help us solve the further thing. Now suppose I have something like this. 10 into 2 upon 5. Or let's say 2 upon 7 for that matter. Now how do I solve this? So very simple here is that when I say 10, I simply mean 10 upon 1. You understanding what I'm saying? You can directly do 10 into 2 divided by 7. But when I say 10 into 2 upon 7, what does 10 here stand for? 10 divided by 1. Because see, if you take 2 divided by 1, it remains 2. If I take 10 divided by 1, it remains 10. So basically, when you divide anything by 1, it remains as it is. And then you solve this fraction. So then what will you do here, children? 10 into 2 divided by 1 into 7. So my answer comes 20 upon 7. Now, why did I teach you all this? Coming back to the question here, you get 2 raised to the 50, raised to the power of 15, raised to the power of 1 minus 1 upon 5. Now, how did I get this 5? The first question is, sir, how did you get 1 raised to the power of? So when you're doing geometric mean, how many numbers are given to us here? 1, 2, 3, 4, and 5. If there was one more number, I would have done 1 upon 6. If there are 10 numbers, I will do 1 upon 10. So how many ever numbers raised to the power of 1 upon those many numbers? Okay. Now, how do you solve this further? You can even leave it here, but if you have to really solve it further, take only this part here. So you'll remain 2 as it is. Raised to the power of 15 into, outside the bracket means you multiply, 1 upon 5. So again, for your understanding, I'll just make 2 a little bit more bigger so you'll understand this. So this whole thing is 2 raised to the power of 15. Outside it's multiply into 1 upon 5. Now this fraction we need to solve here. That is why I was teaching you multiplication of fractions. So when you want to solve this fraction, it is very easy. You take 15 and multiply by 1. So my answer comes to 15 upon 5. If you want to do it in a longer way, how will I do it? 15 into 1 upon 5 actually means 15 upon 1. When it's only 15, I repeat, it simply means 15 upon 1. Are you understanding what we are doing?
हाँ
Yes,
Please,
sir.
बनूंगा
please mute yourself, children. If there is noise behind you, we are recording this session. Okay. So now what you will do, you will take 15 multiply by 1 and 5 multiply by 1. So you will get 15 into 1 upon 1 into 5, which is further written as 15 upon 5. That's how I got this particular calculation. Okay, so that's why I was teaching you the multiplication of fractions here, which I showed you both examples. When you get 1 upon 2, 1 upon 2 into 2 upon 3 is multiplication, means 1 into 2 divided by 2 into 3. So 1 into 2, 2 into 3, 2 upon 6. But when it's only a single figure, you just put like this. In this case, what I showed you, when 15 is given, so it means 15 upon 1. This comes in. So now if you see further, 15 and 5 can get cancelled because 5 ones are and 5 threes are. So your final answer will be 2 raised to 3. Why 3? Because again, it's 3 upon 1. And 3 upon 1 means same as 2 raised to the power of 3. Have you all understood this? Yes, no? Have you all understood?
Yes, sir.
Okay. Now, next part. Let's take another sum similar to this, where we don't have anything as a common base. So let's say the data is 3, 7, 5, 9, 11. This is your data. So what do we do? In this case, you'll have to simply do 3 into 7. I'll add one more number, so you'll two more numbers, so you'll get understanding what happens when more numbers are there. Into 5, into 9, into 11, into 13, into 17. How many numbers? 1, 2, 3, 4, 5, 6, 7. So you'll have to do raised to the power of 1 by 7. Is this clear with you?
Yes, sir.
So that's all you leave the answer. At the most, you can further under root. This is 7 and 3 into 7 into 5, or you can solve it and write whatever the output is and leave the answer here. Okay. Achha, by the way, in a couple of classes, I'm going to start with graphs. I'm just waiting for you all to get your graphs ready, because I need to teach you graphs. So you need to have a graph paper. Are we clear? And don't take the small
Yes, sir.
graph books. Take the
Big one, A4.
A4 size. Yes. Make sure you have a big A4 size book. Don't take those teeny mini books which you had in school.
Yes, sir.
No. Moving further, we are now moving on to something very easy actually. Earlier was measures of central tendency. Now measures of dispersion. Achha, what is central tendency is? Basically, central tendency means something which lies in the middle. You know, like in median and all, we want to find out something which is exactly the center point of anything. Here, we are finding measures of dispersion. Now, what is measures of dispersion is basically, once you find your central observation, which is your average observation, you want to see how much deviation is there, deviation from the center. Means, you know what, if I get my mean as 10, how far are the other numbers from 10? Means what is the dispersion data percentage, or rather means how far or how scattered is my data. That is the meaning of the measures of central dispersion. Is that clear? So if your data is close to your mean, that means data is not very scattered, you know. But if you find when your answers comes very huge, that means your data is highly scattered. Okay. So measures of dispersion means from the central point, how far is the other observations running around? Means what is the distance they are deviating from the mean. Okay. Now, the first part in that is range, which is the easiest. We are having range. What is the formula for range? Highest observation minus smallest observation. Highest observation minus smallest observation. Write down the formula, please. highest observation minus smallest observation. Okay. And coefficient of range is highest observation minus smallest observation divided by highest observation plus smallest. Now, if you want to put it in shorter terms, you can just write h minus s for range. And for coefficient of range, you can write h minus s divided by h plus s. So h minus s divided by h plus s. I'll just get my s not to look like a 5. Okay. Now let's take up a sum for this matter. So I'll give you a certain data now. You also write down the data. 10, 100, 124, 59, 75, 111, and finally we have 116. This is your question. Can you see this? The
Yes,
question
sir.
says find range and coefficient of range. Find range and coefficient of range. So when you're finding range, what is the formula for range? Range is equal to h minus s, if you want to put it in formula terms. That is highest observation minus lowest observation or the smallest observation. In this entire series, what is the highest observation in the numbers which are given to you? What is the highest number do you find here?
124.
Very
124.
good. And what is the lowest?
10.
10. Finish. That is the answer you get. 124. Write it a little bigger for you. Minus 10. So what is your range? Range is equal to
114.
finish. Yes, that's it. 114. Now coefficient of range. What does it say? H minus S divided by H plus S. H minus, let me tell you, some people also write the formula as L minus S. If you find in some books, don't get confused, children. Formulas can be different. There are different formulas in EMI also, standard deviation also. Answer comes the same. Now, what is L minus L? S, some write largest instead of highest. Instead of highest, some people use the word largest. And some people for smallest also use the word lowest. So these are just synonyms, same words, same meaning, different words. So don't get confused with that. Okay. So our answer here, highest observation in this case was 124 minus 10 divided by 124 plus 10. And now you can directly do it on your calculator. Or you want to write one more step, you can write 114 divided by 134. The answer comes to 0.8507. Write it as 4 decimal places, this one. 0.8507. Are we clear with this?
Yes.
Yes, sir.
Yeah, 0.8507. Now let's take up another sum, similar sum, but in a grouped data. So if you see the screen right now, you'll find a group data. I'll just import it to the board. And you can see it now. Now suppose I ask you, find range for this. Okay. Again, our same question lies here. Find range and coefficient of range. So how do we do this? So basically, range, the earlier one was ungrouped data. This is group data. So the formula for range remains the same. Range is equal to, if formula wise you are writing H minus S. Now here, what is the highest frequency, highest observation? Understand, now it is not highest frequency, it is observation. So when you're talking about range, even mean, median and mode, see this frequency column is not important. Your mean, median or mode always comes as an answer from one of these. So your range will also be here. You have to see the data given in the class. What is the lowest data given in the classification? 0. If you see here, our lowest data is 0.
0.
What is the highest data? 80. Okay. So if you want to know the range of marks, let's say class means marks. Or even make it easier for you, this is the speed of a bike. You all ride two-wheelers and this is the speed of a bike. So what is the slowest a bike can go? 0 kilometers per hour. That means standing at one place. And what is the highest speed you should achieve? 80. Okay. So here in this case, your range formula will be 80 minus 0. So your range is what? 80. Are you understanding this?
Yes, sir.
Moving further for coefficient of range. Coefficient of range. Now under coefficient of range, our formula says H minus S divided by H plus S. So what you have to do here is, we have 80 minus 0 divided by 80 plus 0. Answer will be 80 upon 80. So your answer would be 1. Is this clear?
Yes, sir.
Yes, did you all understand range?
Yes, sir.
Okay. Let's take another sum. Now let's find out range for another sum. Okay. So let's take another data here. I'll just clear the screen, children. So write down 36, 15, 25, 10, 14, and 100. This is your question. Now come on, help me find out in this case range. So range formula,
10 minus 100.
range is equal to, yes, what is the formula? Anyone remembers the formula now?
H
F minus S.
Yeah, H minus S. So what is the highest here?
The 100
100.
minus
Sure.
10.
100.
Yes.
And what is the lowest we have?
10.
10.
So you are going to have 100 minus 10, which is equal to 90. Okay. Similarly, coefficient of range. H minus S upon H plus
S.
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 So we are having our highest as 100
Yes, sir.
plus, sorry,
100 plus
10, 100
100
minus
minus
10 divided by 100 plus 10. Okay. So you're going to have 90 upon 110. Anyone got the answer? Okay, now the answer comes 0.81818,
Yes,
5
sir.
decimal. So technically rounding off this, you have to look at the 5th decimal place. If it is more than it's 5 and more, then the 4th place becomes 1 extra. But yes, some people who find a little difficulty in rounding off, you can leave it as 8181, but the technical rounding off should be 8182. 8182. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Now I'll take another sum. Now we'll do it for group data. Take this as your sum. So again, range is equal to H
H
minus S.
S
Okay. So our highest, which one will you take now?
70.
Okay, correct. So you search it in this section here, lowest and highest. So you will have answer as 70 minus 10. 60. And coefficient of range is equal to H minus S divided by H plus S.
S.
So we will get it as 70 minus 10 divided by 70 plus 10. So answer comes to
0.75.
3.25.
correct. This is the sum here. So range is easy.
Yes, sir.
Yes, sir.
Earlier it used to come for 2 marks, but now with the MCQ and all questions have become 1 mark, children. Most probably everything is MCQ. Now, I want you to write down the formulas. We'll begin this in the next class. Standard deviation. Okay. Now standard deviation, also there are different formulas. This is the formula I use, find it very convenient to use it. Okay. So standard deviation for ungrouped data, and we also have grouped data. So we have ungrouped and grouped data. So write down for ungrouped data. So standard deviation under ungrouped data is sigma d square upon n, sigma d square upon n upon minus sigma d upon n the whole square. Now here in this case, what is d? The prior class we already studied d. Anyone remembers what is d? When we did step deviation method in mean, d is equal to x minus a. Do you know what a stands for?
I think
Assume
assumed
mean.
mean.
Correct. A stands for assumed mean. That means you can take, now we discussed range, correct? Just now we discussed range, na?
Yes, sir.
Yes,
So
sir.
basically assumed mean, whenever you're taking assumed mean, I'll just take it to range and I'll explain it to you here. When you're talking about assumed mean, what you can do here is, like for example, we have this highest observation and smallest observation. Like in this case, it was 110. So it was 100 highest and 10 lowest. Between that range, you can take any number to be your assumed mean. For example, in this series, if I have to find assumed mean, I can take 11, I can take 13, though the number is not here. The only rule is it has to be between 10 and 100. Did you understand this?
Yes, sir.
So even here, in this case, see group data, your assumed mean can be anything between 10 and 70. So that is the meaning of assumed mean. Okay. Now coming on, the next is variance. which is SD square. Now you'll wonder what this down round here is. This is basically the symbol for standard deviation. Like mean is X bar, standard deviation is like this. This is the symbol. So these are the symbol for standard deviation. So variance is equal to, or variation is equal to SD square. Coefficient of variation is SD upon mean into 100. There is SD here I'm using for standard deviation. Okay, so in formula terms, if you want to put this SD upon mean into 100, it will appear like this upon X bar into 100. Both mean the same. One is symbol wise, one is writing the data. Okay. Now we have grouped data. So group data formula says sigma FD square upon N. Achha, N I forgot to discuss. I'm sorry, but N we have already discussed many times. What does N in these sums mean?
Number of observations.
Great, excellent. Number of observations. So when it comes to measures of central tendency, remember it is always number of observations. Now, when it comes to group data, we have sigma FD square upon N minus sigma FD upon N the whole square into H. What does H here stand for?
Interval class.
Class interval or height of a class. Actually, many people or many books take H. H represents the word height. You can also take I representing the word interval. Now D, I taught you a shortcut yesterday for D, if you remember, day before, sorry. In this case, D is X minus A upon H. This is the formula for D. I'll just put my X proper. It is looking like an N, sorry. X minus A upon H. This is the formula. But we are not going to use this for D because we found out a shortcut. I taught you that shortcut, remember? Whenever there is group data and you want to write D, just write 0, 1, 2, 3, 4. Do you remember that? Or place 0 in the center and then write minus 1, 2 and 3 on the top and 1, 2, 3 down. So that trick I'll teach you when we reach that particular sum.